Hello Legacy students, Marsh here. So today we're going to look at natural logs, and no, these are not logs that grow in a forest. We're going to want to look at your notes, your pen or pencil, and then you're definitely going to want your scientific calculator out today so you can find certain buttons that I'm going to talk about. So guys, what we're going to talk about today is a special type of log. So you guys have heard of the common log. That was when there was base 10. That was the LOG button that was on your calculator that we've been working with logs. Now your calculator is normally set for a base of 10. Now there's such a thing called a natural log. What that is, guys, is it's basically a log with a base of e in it. And normally what you're going to see that called is called ln, because it does pop up so often that they actually gave it a special function name to it. So log with a base of e, which would be about 2.71, right, would just be equal to ln. So keep that in mind. Notice, guys, there is no little e there because the log base e is just ln. So normally you will not see a little base on ln because that means that it's log base e already. Okay? So go ahead and grab out your little foldable. It's a natural log with a base of e. I thought it was pretty good myself. You know, natural log base of e. That was pretty good. Now you're probably asking, what is a natural log? Well, a natural logarithm is a logarithm that has a base of e. Basically, it's the inverse of y equals e to the x. And your abbreviation is ln. Now, it's without a base, but you should know there should be an e there. There is technically an e because it's log base e. Now, on your calculator, normally you'll find it. It says ln right here. It was probably the button you push to get e to the x. Try to look for that quick on your calculator. Make sure you have an ln button because we are going to be using it pretty heavily today. So you take a moment, pause me up, give me some pause here, and then double check to make sure you find it on your calculator. Let's go forward here. Let's talk about converting from ln form to exponential and then exponential to ln. So, ln form, guys, I like to rewrite here. So this technically is the same as log base e of smiley face equal to $. Now, we practiced how to convert logs to exponentials, remember? So, it was what base, e, to the x answer, exponent, equals the value. So it'd be e to the $sign equals smiley face, ultimately. Notice, guys, these are equivalent forms. Log base e is just ln. So ln and log base e are the same thing. All I'm doing is making sure I can see that base on it, on that log, so it makes it easier for me to convert to exponential form. Now, what about ln of 1 equals 0? So I'm going to just convert that here to log base e, because remember, ln is just log base e. Then I got 1 equals 0. So I got e to the 0 power equals 1. So e to the 0 equals 1. Double check that is a true fact, because remember, anything to the 0 power is in fact equal to 1. Now let's go backwards, guys. So it's going to be log base e of the 54.6 equals my exponent, so 4. So e to the 54.6 equals 4. That's what we got. Now log base e, that is not simplified. We're going to convert that so it is ln of 54.6 equals 4. Because remember, guys, ln and log base e are exactly the same thing. No difference there. Now let's rewrite in natural log form and then solve for x. So I can rewrite this with the log form. So that would be log base e of 148.413 is equal to my exponent, x plus 1. Now, log base e of 148.3. This is technically ln of 148.43, right? Now, you're probably saying, Marsh, how on earth do we know what that is? Well, you can find what ln of 148.43 is on your calculator. So go ahead and quickly find that ln key that I was talking about earlier. and type in ln of 148.43. You get something really close to 5, right? It's like 4.999, something like that. So I rounded it up to 5. So ln of this is equal to 5. So I got x plus 1. So let's solve for x, subtract 1. So I get 4 equals x for my answer. Let's try the next one. ln of x equals 2.639. So ln is the same as log base e. So all I'm doing is just substituting an equivalent form in. Now let's convert to exponential form. So e to the 2.639 has to equal x. That's what it looks like, right? Well, you guys have practiced finding e to a number, so go ahead and type that into your calculator quick. And you get like 13, really close to 14. So I rounded up to 14 equals x. So e to the 2.639, that is e, or is 14, excuse me. Now, what about evaluating in your calculator? Let's plug some stuff in. So negative 2 times ln of 4. All you guys are doing is you're typing negative 2 times ln 4. Enter. That's all you're typing into your calculator. These are total calculator problems. So you should get negative 2.77. Double check, make sure you're getting the same numbers as me. 1 plus 4 ln of 6, that is 8.17. All you're doing is just typing straight into your calculator, guys, just straight in. 2 times ln of 4 plus 3 ln of 5, that is 7.60. This is 5.38. 3 times ln of technically 6, because it's 5 plus 1, right? Negative 3 ln of 10 plus 1 is negative 5.91. And this is 6.66. Negative ln of 4 plus 5 ln of 5. Now, please, 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 I implore you, please figure out how to get these in your calculator. Please make sure you know how to, as that is the main bread and butter of this section, is knowing how to get ln and typing it into your calculator to actually get an answer or a value for that particular expression. But until then, that's the end of this video. See you later, Sabers.